Okay, friends. Today we will be going through the AI in reality. Okay, so we will see what are the uh, problems which are being faced while we are using AI models, generative AI concepts. Okay, and we'll also find out the solution. What is the solution we are having? So the first things, if you have already used an AI model, anything like ChatGPT or Gemini, Google Gemini, or lots of other models also which are available. If you have used, you must have seen like you are expecting some result like X, but you are not getting that value. You're getting some other different value which is actually not your expected, or kind of a false positive output, which you are not targeting for. Okay, in that's the problem which we call in the LLM. We say it has a LLM hallucination. Okay, so basically, a model can produce text that is incorrect, nonsensible, or unrelated to the reality. Okay, so kind of a false positive, which you are not expecting that output you're getting from an LLM. So basically, you're working in any of the company, and if you're asking him, tell me the leave policies, in that case LLM may be trained with some other companies, and it will be giving you the output of, let's say, uh, Y company. Okay, LLM is been trained, and you're working on a Z company. Okay, at this point you are asking an LLM, give me a leave policies. Okay, in detail. So output will be related to the uh, Y company, because the LLM is already trained with Y company data. Okay, so if Y company is having in a year 10 days leave, okay, 10 days holidays, and your company may have 12 days holidays in a year, at this point you are getting a wrong output. You are asking for your company, but you are getting for a Y company data. Okay, so uh, this problem, how we can fix? Okay, what is the solution for this? For this we are having a reg, retrieval augmented generation. Okay, one of the very good concept which have been there for solving this kind of LLM hallucinations. Okay, process that combines a retriever and generator to ground answer in a fact. Okay, so now what you will be going to do in a reg is that you will be training your model with your data. So your Z company will be having documents like leave policies, PDF, and all those things documents will be there. Now you will be giving this data for your LLM, and after that when you will be asking, tell me the leave policy. Okay, at that point you will be getting a correct output, which is your expected output. Okay, so now how, what are the steps in this reg? Okay, so first step is ingestion and chunking. So basically I was just talking about the leave patterns or holiday things, but there can be lots of data which is there in an HR field or HR module. Okay, wherein will be lots of data. So now we need to train our model with this lots of data. So data ingestion, there can be different types of formats for data. So those things we need to take care. Data ingestion, chunking comes when we are having a huge data. We need to make small piece of that chunking and then train this LLM. Okay, so documents are ingested and broken down into smaller manageable chunk of text. We when we are coming with an LLM, at that time we are also getting the tokens things. Okay, so to train this LLM and all those things, we need to chunk the data and then we need to train. Okay, we can't put like 50,000 lines of data at a time. We can't do that. We need to chunk like 5,000, 5,000, 5,000, 1,000, 1,000, 1,000, depending on what chunking patterns you are using. You need to work on that. Okay, then second thing is an indexing. Okay, so basically now this chunk data you can see in the diagram, like how we are doing, the chunks are being created, and then now we are creating the vector embeddings. Okay, each chunk is converted into vector embedding and stored in the vector database. Okay, so basically vector database, you must have heard about cosine similarities and all those things. So like similar things like what you are that we will discuss in the retrieval part. So basically we are storing these chunks in the database in a vector form. So uh, you must have seen general database like Postgres, SQL database, wherein you are just storing the data. But over here, you are making use of a vector embeddings and storing it in the vector database. Okay. For PG admin, I don't remember the name of vector database, or something called PG vector or something is there, wherein which you can use. Okay, then GraphQL, Neo4j, but it's a graph database. It's something different. Okay, wherein you can also store these chunks in the graph DB and Neo4j and DB. Okay, next thing is a retrieval. Now, once you're storing, you need to get this data. So, user query is used to find and retrieve the most relevant chunk from the database. Okay, so over here we can use some like cosine similarities, wherein we can find the most uh, nearest to the whatever a person is searching in an LLM. Okay, so generation, the LLM uses the original query and retrieve the chunk of the generated function and answer. Okay, so over here you will be getting a new output which is appropriate for your input. Okay, the core array component. Okay, so vector embeddings, you can read more about this vector embedding, mapping text into the high dimensional space where similar text is represented by the similar vector. So as I said, cosine similarities is one of the things which you can use to find out the cosine values. Okay, which is the nearest to the other mapping thing. Okay, chunking, it's a process of breaking large document into smaller pieces for effective retrieval. Okay, and tree splitters are there are lots of chunking methods which are present. You can search for chunking also. And then vector database, specialized database designed to effectively store and query vector embedding using a similarity search. Okay, so yeah, that's it from my side for the today. What what we have in the AI in reality, and just an introduction to the array. Thank you so much.